This is the DataVerse Podcast, brought to you by STFC.
Hello and welcome to the DataVerse Podcast. I'm Pollyanna, and today I'll be talking to Jian Fang, who is a computational scientist working at Daresbury Laboratory. Jian primarily studies computational fluid dynamics, or CFD, which means he uses high-performance computing to simulate the flow of fluid particles around an object. This work has wide-ranging applications, but today we'll be focusing on Jian's research into the exciting future of hypersonic vehicles. Hi Jian, welcome to the DataVerse Podcast. It's great to have you on today.
Hi Pollyanna, it's great to have this podcast.
So, what does it mean if a vehicle is hypersonic?
Well, by definition, it simply means the vehicle is traveling with more than 5 times of the speed of sound. So it may not very common in our everyday life because most of our vehicles is subsonic, is lower than the speed of sound. Even we take airplanes, like commercial airlines, is also like close to the speed of sound, but lower than the speed of sound. So the modern military aircraft can fly with like 2 times less than 3 times the speed of sound, but hypersonic vehicles is at the next level. They travel much faster than the current ability of the vehicles or even the military airplanes.
So how can high-performance computing help us build hypersonic vehicles?
That is an excellent question. In terms of hypersonic vehicles, the computation is so much relied on more than ever, because when in history, when people design like conventional vehicles operating at a lower speed, they use a lot of wind tunnels. They put like the model airplane in the wind tunnel and test and mirroring the something like a drag, the lift, the torch, so they can design the flight characteristics properly. But in the hypersonic vehicles, the hypersonic wind tunnel is too big and too expensive, and the testing time is too short. You basically cannot get too much information from the measurements. That's why the engineer will hugely rely on the computer. They need the simulation to get the aerodynamic characteristics of something like the lift, the drag, the thrust, everything related to the hypersonic vehicle. And they also need the high performance computer to do something like the optimization, design, all in the entire design loop of the hypersonic vehicles. So I would say like the HPCs, it will be hugely involved in the engineering design of hypersonic vehicles.
So what research are you doing specifically?
Okay, so my basically research is to use the HPC or to do something called direct numerization or large eddy simulation of high-speed flow. So basically we use a very fine mesh, which means a lot of computational resources required to resolve very, very small scales of the flow structure in the hypersonic flow, so that we can simulate everything accurately and with a lot of the flow details. So this kind of detailed database provide a very good advantage for the research of aerodynamics. Also provide accurate the data to calibrate and validate the engineering models. So I did most of the things related to this topic. So we designed the advanced schemes, high-performance software. We also conduct the large-scale simulations of high-speed flows. We get the database of high-speed aerodynamics, and we also develop engineering models for the aerospace industry. And some of the models are indeed being applied by the company like Rolls-Royce in their engineering design.
So what are some of the benefits of hypersonic travel and hypersonic vehicles?
The first thing people might get from a hypersonic travel or hypersonic vehicle is save a lot of time. The hypersonic vehicle can make people something like travel from London to New York within 1 hour, and you can come back with another hour. So you save a lot of time. So it literally means a huge revolution for the international travel. Literally, people can living in a place on the planet and working in the other end of the planet. And also it means it might have the chance to save the energy of fuel conventional airline we currently take is like flying under like something like 20 kilometers above the Earth. But the hypersonic vehicle we're operating at a much higher altitude, something like 50 kilometers above the Earth, which means lower density. And that means lower aerodynamic drag. So with a lower drag, you probably need like less energy to generate the thrust. And also you get like a short time of the journey, which that probably can make us save a lot of the energy, the fuel, and means like our travel will be more green.
What other applications are there for hypersonics?
Yeah, this is another very good question. So I think besides like taking passengers from one end of the Earth to the another end of the Earth, there's a lot of potential applications for hypersonic vehicles. The first thing is like in the aerospace. Because currently people use a rocket to launch like something, a satellite or like astronaut, but we all know that the rocket is very expensive, and most of them can only use by one time. So because you have like a very large first stage of the rocket, and most of them is with fuel, and hypersonic vehicles have the chance to replace the first stage of the rocket, because it's within a similar speed range of first stage of the rocket, and it saves a lot of the energy, because hypersonic vehicle does not need to carry oxygen with it. It takes oxygen from the air, so which means that a lot of the reduction of the total weight. Light rocket means a higher payload of the rocket. And the other place of the applications of computational fluid dynamics, I will say, is a lot of things. It's not just in the flying vehicles, can be also in the conventional vehicles. Currently, people are using like CFD in the simulation of ground vehicles. Like as far as I'm aware, F1 car companies use CFD to reduce the aerodynamic drag or improve the aerodynamic performance of like racing cars. Also, like the heavy lorries, they use CFD to like optimize the aerodynamic shape of the lorries to try to reduce the drag. So I'm also doing something in like a drag reduction, or we call the boundary control, to get some like optimized performance for different types of vehicles. I think the CFD technology is kind of a universal science and technology, can be used in the different scenario in the engineering world.
So thank you so much for coming on the podcast today, Jian. I've learned so much, and it's really exciting to hear about the future of travel and aerospace and all other sorts of applications for CFD modeling.
Thank you for such a great opportunity to explain what I'm doing or the importance of hypersonic vehicles. We really hopefully in this country more things will happen in the future.